In last video, we have discussed about the uniform circular motion, and in this video, we will discuss the difference between uniform circular motion and straight line motion. So, in a straight line motion, uniform straight line motion. This is uniform straight line motion. Consider an object is moving on a straight line path with constant speed. So in uniform straight line motion, what I have told you, uniform means constant speed. In uniform straight line motion, speed of object is constant. Direction of motion of object is also constant. That's why the velocity remains constant. Okay? Velocity is also constant. Actually, you can say velocity contains two things. One is speed and other is direction. Velocity is a vector quantity. This is a vector quantity. Velocity is a vector quantity. It means it contains two things, magnitude and direction. The magnitude of velocity is called speed plus direction. In uniform straight line motion, the speed of object is constant and the direction is also constant. So the velocity remains constant. Velocity remains constant. Due to this, there is no acceleration in uniform straight line motion. So this is the uniform straight line motion. In uniform straight line motion, the speed of object remains constant. The direction of motion of object is also constant. That's why the velocity of object is constant. And if the velocity is constant, there is no change in velocity. According to the formula, acceleration will be 0. You know acceleration is equal to rate of change of velocity. So if there is no change in velocity, so acceleration will be 0. This is the uniform straight line motion. Now, in uniform circular motion, the speed of object is constant, but velocity does not remain constant due to change in direction. Velocity changes continuously. So there is a non-zero acceleration which acts toward the center of circular path, and it is also called centripetal acceleration. So there is a difference between uniform circular motion and uniform straight line motion. Uniform circular motion is an unaccelerated motion because acceleration is 0. But in uniform circular motion, it is an accelerated motion due to variable velocity. Now I will explain you centripetal force. As you know, if a body moving on a circular path with constant speed, there is an acceleration acting on object toward the center of circular path. This is the center of this circular path and this is the radius r. If a body is moving with constant speed, then an acceleration acts toward the center of circular path due to change in velocity. This acceleration is called centripetal acceleration. According to second law of Newton, as you have studied in class 9, what is second law of Newton? F is equal to ma. The simplest form of the second law of Newton, F is equal to ma. So, if there is an acceleration, so this acceleration is due to some force. It means if a body is moving on a circular path, some force should be acting on this body towards the center of this circular path, due to which this acceleration comes. This force is called centripetal force. Okay, so the centripetal force is that force due to which an object can move on a circular path. This is the force which keeps a body on a circular path. It is called centripetal force. And as you know, the direction of acceleration is toward the center of circular path, same as this force is acting toward the center of circular path. This is called centripetal force. The expression for centripetal force is equal to F is equal to mv square over r. This is mass of object which is moving on this circular path, m, v is speed, and r is the radius of this circular path. So the centripetal force is that force which keeps a body on a circular path. Without this force, it is not possible to move a body on a circular path. This is the necessary force which keeps an object on circular path. This is the mathematical expression for the centripetal force. You know, Earth, this is Sun. You know the Earth is revolving in a circular orbit around the Sun. So, the motion of Earth is uniform circular motion, and this motion is only possible due to some centripetal force. In this example, the centripetal force is the force of gravitation between Earth and Sun. If you tie a stone with a string and move it on a circular path, then the tension produced in that string is the necessary centripetal force which keeps the stone on the circular path. So this is the centripetal force. Now there is another force, is centrifugal force. Centrifugal force. It is virtual force. Virtual force or pseudo force. Actually, a force assumed to be acting on a body in direction opposite to center of circular path. It is called centrifugal force. Consider a body is moving on a circular path. So the force which is acting toward the center of circular path is called centripetal force. Centripetal force is a real force, but centrifugal force is also assumption of viewer. Okay, it is a virtual force. So the force assumed to be acting on the body, a force assumed to be acting on the body in direction opposite to center of circular path is called centrifugal force, and it is not a real force always given. This is the centripetal force. Now this chapter, the theory of this chapter has completed. In exercise B and C, all questions are theoretical. First you read the chapter and try to solve these questions. If you have any problem, you can comment. In next video, we will discuss some theoretical exercise of first chapter.